That's good enough. It's 5.1. All right, so let's look at 5.1. Like I said, we'll do a little bit today just because we had a time, and then we'll go from there. Okay, I'm losing. You guys can see my screen, right? The 5.1 up there? Okay, for some reason you guys keep going off. I wasn't doing that earlier, so feel free to unmute or something if something goes out. Let me know. And also, bear with me. I'm still trying to get used to writing on your screen. All right, so 5.1 is angles in radian measure. Yeah, that didn't work out right. All right, so standard position of an angle. An angle is in standard position if the vertex is at the origin of the rectangular coordinate system and its initial side lies along the positive x-axis. All right, so just two generic examples of your what it means for an angle to be in standard position. So your initial side, well, first of all, your vertex is at the origin of your rectangular coordinate system. Your initial side is your positive x-axis, and whether it's going clockwise or counterclockwise as far as the direction of your angle, as long as your initial side is at the positive x-axis and your vertex is at the origin, your angle is considered being in standard position. All right. That doesn't look good. All right, so positive angles are generated by counterclockwise rotation. Negative angles are generated by clockwise rotation. So this one up here is positive, and this one over here is negative. All right. Um, all right, so we got four types of angles, but have a limited space that I'm using to scroll up and down. So go ahead and knock out the first two. You got your acute angles. They're between 0 and 90 degrees. Your right angle is exactly 90 degrees, and either it needs to be said in words or you need to see that box um, in your angle formation in order for you to know that it is 90 degrees. You can never assume that you have a 90-degree angle because to the naked eye, 89 degrees, 91 degrees will look like 90 degrees, depending on the drawing. So you want to make sure you see that square in that drawing, or it is written somewhere that this is a 90-degree angle. Looking for that. I can draw that one better. All right, and the next two, got an obtuse angle is between 90 degrees and 180 degrees. Then your straight line or your straight angle is 180 degrees. And I didn't mention this one either, but I can. Don't say full rotation. So the other one, not necessarily one of your types of angles, but just as far as notation is concerned, if a rotation is mentioned or a revolution is mentioned, that's 360 degrees. Any problems so far? Let's see. I won't go with definition. If you want to know the definition of radian, I guess you guys will look that up. But let's look at actually calculating with a radian, which really matters. Yeah, one black. Let's go radian. Ooh. All right, so radian measure. So we consider an arc length S. So we're talking about arc length, the length of this arc right here. So, oh, didn't mean to delete it all. Get my circle back. All right, so that's your arc length. So we calling this arc length S. And then your radius, don't forget the radius of your circle will just be from the center to any point on your circle. The measure of the central angle, theta, that's Greek letter theta, that intercepts the arc is S over R radians. Okay, so first example, a central angle theta in a circle of radius 6 inches intercepts an arc of length 15 inches. What is the radian measure of theta? So this type of problem is more so about establishing what numbers go with which variable, and then after you do that, you just plug it into the formula. So we have the central angle theta. That's the one we're trying to find out. Because remember, it asks us what is the measure of theta down at the bottom. In a circle of radius 6 inches, so that means R6, intercepts at an arc length of 15 inches. So S is 15. They tell us to find theta. Theta is S over R. So that's 15 inches over 6 inches. You got to be careful here. If by some chance they gave you one in a different measurement, you would have to convert them. They do need to be in the same measurement so that your measurements can cancel out. We have inches over inches that will cancel out for us and leave us in radians. If you were to go back, notice after you do the calculation, radians is what your measurement should be. So it shouldn't be inches radians or inches feet radians. So your measurements that you're dealing with have to be the same so that they can cancel out. And what you're left with is just the radians from the actual formula. So finishing it off, 15 divided by 6, 2.5 over, yep, 2.5 radians. All right. Questions on that before we go to do at least one more thing before we close it out today. That's between. Okay, so relationship between degrees and radians. 360 degrees is equal to 2 pi radians. 180 degrees, that's halfway, is equal to pi radians. Converting, right, that's what I am. All right. So, yeah, I'll do it that way. All right, so converting between degrees and radians, going to multiply. If we're going from degrees to radians, you'll multiply by pi over 180. If you're multiplying, not even multiplying, if you're converting from radians to degrees, you're going to multiply by 180 over pi. I left off my radians down here. Yeah. All right, so we'll do a few of those and then we'll call it a day. All right, so first one, directions say convert each to radians. So we're looking at 30 degrees. So we take out 30 degrees. If you want to set it up as a fraction, you just write it over 1. Multiply that by pi over 180. And if you ever forget which one to use or which order to use it, we need, just like we're talking about inches over inches to cancel, I need my degrees to cancel. So I need, if I'm starting in degrees, I need degrees down bottom so that they can cancel out. If I were to multiply across, 30 pi over 180, So I'm actually, and that should be radians right here. I just didn't write it beside the pi, but I'm actually in radians right now. Now, don't confuse the fact that we're using pi and associate that only with radians. Just because I have pi does not mean I'm in radians. But that radian goes along with the pi in this conversion, because notice we had degrees and radians. But just because you see a pi, you cannot assume that you're in radians. It has to be established. So we got 30 pi radians over 180. So that 30 can cancel out with the 30 that's in the 180, because that is 6 times 30. So that'll leave me with pi over 6. All right, next one, 90 degrees. But yeah, I guess I'll keep the same pattern. So that 90 pi over 180, the 90s will cancel, and that'll reduce down to pi over 2. Last one like this, 135, negative 135, negative 135 degrees. All right, so multiply that across, or go ahead and cancel, whichever way you want to do it. This one was 45. All right, so the 45 cancels, leaving us with negative 3 pi over 4. Before we go to the next one, any questions?
No, sir.
All right, thank you, thank you. All right, so this last one for today, we're just going to take it, go back in the other direction, convert 2 degrees. All right, so we have pi radians, or pi over 3 radians. I'm going to multiply that times 180 degrees over pi radians. Pi radians cancel. 180 degrees over 3. That would be 60 degrees. Any problems? Any problems? All right, so negative 5 pi over 3. Same process. So that pi radians will cancel. Looking at -5 times 180 divided by 3. Instead of multiplying that 5 and 180, cancel out that 3 that's in that 180, that's 60. And of course, you guys can throw it on the calculator. I'm not doing it with the calculator right now, so that should be 300 degrees. All right. Problem before we look at the last one. All right. So C is one of the things I was trying to make sure we, understood going forward. Recognize that there is no pi associated with C, but there is the measurement of radians. So you can never assume. Always got to make sure you see the measurement or see the what type of situation you're dealing with. 2.3 radians. We're in radians. So you still will hold true to the same process in the same format. The main thing isn't the pi, it's the measurement of radians that we're dealing with. So that's 2.3 radians. I'm going to multiply that by 180 degrees over pi radians. The only thing that will cancel out is the measurement of radians. So that'll be 2.3 times 180 over pi. And that would be approximately 31.8. And my math lab will let you know, how many decimal places they want and all the good stuff like that. Yep. So we have 10 minutes left. But this is a good place to stop. We'll finish up 5.1 next class and jump into 5.2. We'll just do it like that. Jump into 5.2 next class. Any questions, concerns, comments on anything?
No, sir, I'm good.
All right, sounds good. Anybody still copying before I stop sharing? Everybody good. All right. So, you guys' main assignment is to go ahead and get into my math lab, see if you have any issues as far as logging on or doing any of your work and all the good stuff like that. And let me know if you have any issues. Outside of that, I will see you guys on next class, which is Thursday. And y'all have a good one.
I have a question really quick.
Yep.
So is there a code to get into my math lab?
Yes, it's in the chat.
Okay.
Are you talking? Make sure that's the one you're talking about, the course ID.
Yeah, the course ID.
Mm-hmm.
I don't see it.
You don't see it? Okay, it is Tucker.
Mm-hmm.
84511.
Okay. Thank you.
Not a problem. All right. Anything else? Anybody else before we clear out? All right. If any questions come up before Thursday, feel free to email me. I'll be looking out. Other than that, you guys have a great rest of your day.
Have a good one.
All right. You do the same.
Thank you.
Yep.